So without further ado, I'm going to introduce you to Rona. We are now so intimately involved in her life that there isn't anything that we're doing now that's the same as it was 9 months ago. However, what I'm trying to make sure that you understand is that come summer of 2021, hopefully we would be wearing this pattern as a beachwear only and not have to worry about all of the trial and tribulations that each and every one of you have gone through. So this particular virus may look pretty in this kind of a projection, but make no mistake, there is no question whatsoever that we are sitting on a pretty angry virus that has infected 15 million in this country, is sitting on 200,000 new cases every day, 100,000 in the hospital, and you're going to be seeing cities shutting down because we're running out of ICU beds, we are running out of vents. There is very little question whatsoever that this is a deadly disease. And in the time frame that we're going to be talking, there are going to be 180 people who died from this particular disease. So there's no question whatsoever that we want a light at the end of a tunnel, and we understand that the tunnel is hopefully going to be relatively short, but no, we're not going to have a Norman Rockwell Christmas celebration. Not going to happen because of the fact that when we wind up letting our guard down ever so slightly over Thanksgiving, this has taken off. And I'm relatively sure that it's going to continue to go perpendicularly up. So this ain't going to happen this year. So for all of you who are wondering what you're going to be doing, we have a remedial course immediately after this session to teach you the etiquettes of Zoom parties at Christmas. And there's no question whatsoever that, again, we're going to be doing things very, very differently. But the important thing is that hopefully we can sort of stay put long enough so that the hope of a different 2021 is going to come about. And obviously, a lot of it is going to reside upon the fact that we have a vaccine at the end of the tunnel. Now, I just want to go through very rapidly some of the terminology that we're going to be using day in and day out, and you've heard it 100,000 times, because people are muttering about T cells and B cells and neutralizing antibody as if you're supposed to know what that is all about. Well, let me just tell you that a lot of the people writing about it don't know what it's all about either, but the basic premise is that we have Rona with a very one-track mind. It is a very simple virus with a lipid envelope. It's got RNA material in the middle, makes a whole bunch of proteins that winds up impregnating itself into the cellular membrane, but most importantly, it have all of these attachments called a spike. And these spikes are going to be important in the virus's natural history and also in what we do with the virus. The one-track mind is that they're going to keep reproducing, and make as much of the virus as they can, utilizing your cell and utilizing your own machinery. So they will reproduce. So let's take a look at what life is all about for Rona. What she's going to do is to understand that there are only two missions in life. Because in order to reproduce, it has to be able to gain entry onto the inside of a cell and then use the machinery that is already there to wind up producing hundreds of thousands of copies so that it can really overwhelm the host. The second thing that it is going to wind up doing is to make sure that it creates a situation that the cell is going to be its own factory. But first of all, in order to gain entry, it is going to utilize a spike protein. The spike protein is like a three-prong hook, and it is going to attach itself to a receptor on the cell membrane called the ACE2 receptor, And then this entire thing is going to be pulled onto the inside of the cell. Once it is on the inside of the cell, it is going to utilize the machinery of the inside of the cell to make a lot of virus and eventually create a situation where thousands of viruses are going to be released from the virus factory. Now understand, the virus factory is actually our own cell. Now, the thing that's going to be important is that Mother Nature has figured out a way to deal with all of these pathogens. And the first thing that they're going to wind up doing is to try and see what they can do with the free virus and try to make sure that they don't gain entry onto the inside of a cell. So to do that, there are lymphocytes or white cells in the bloodstream that's going to be making antibodies. And the antibodies are denoted by these little Y-shaped type of symbol. And these are going to attack the free virus, and it's going to create a situation where they kill the virus that is free. However, this is going to take a lot of antibodies in order to be able to neutralize this particular agent. And once it gained entry into the cell, we've got a different problem, because you can't use the antibody to fight the inside of the cell. So what we then do is to understand that those cells have to be killed in order to destroy Rona's virus factory. And the way that we wind up doing that is to activate a different set of white cells, the T lymphocytes. They're going to basically attach to the membrane of the infected cell and actually destroy it. So they're going to be killing Rona's factory. So in essence, our defense mechanism is our immune system. And they're going to wind up being B cells doing a battery of antibody production, T cells that are going to wind up killing the infected cells. This is about as simple-minded a way that I can present the immune system, because when you allow an immunologist to go to town, they're going to be very specific about what this entire cascade of things are going to be. And all of a sudden, you get this incredible array of different antibodies that are going to be produced. So here it is. This is a time when the virus attacks the cell and gets into the body. And then you're going to wind up with the antibody production with a whole series of different immunoglobulin that have different function being produced at different timeline in the life history, but all of them are directed to kill the free-floating virus. At the same time, you're going to have a whole series of T cells. They're called CD4, CD8, T helper cells. All of these are going to wind up killing the cells that have been infected. So the two wind up going through a life cycle so that they would be able to eliminate the virus. Now, that part of it is important for the first infection, but what is unique is that the minute that they have been infected once, these particular cells basically reside in the system and they have long-term memory. And if you wind up exposing yourself to the same virus again, what you're going to do is to have a second response of B cells and T cells all coming out pretty promptly so that the infection will never actually take hold. And this is the memory so that you don't wind up getting fooled a second time by the same virus. Now, once we know that that's the way that the body's system help with the pathogen killing, then what we're going to wind up saying is, instead of being infected by Rona the first time around, what if we make some fake Rona that's not going to wind up damaging the host, and we're going to wind up introducing it. The body is going to mount its immune response, and when it does that, it is going to wind up saying, hey, what am I running around for? This isn't even a real pathogen, but nonetheless, they can remember the target. And once they remember the target, if you should actually confront the real virus, you're going to wind up being able to mount an immune response. And that's exactly what's going to be happening with all of the vaccines that you're going to be listening about. First of all, You make a target that looks like the virus, and we'll call it fake Rona. You then inject the fake Rona into the human. They are going to mount their B cells, T cells responses. They're going to fight basically nothing. They're going to run around a little bit and then quiet down. But the next time that you see Rona again, the B cells and T cells are going to come out pretty promptly, and you're going to get into a situation where you would be able to destroy the virus. So everybody looking at this coronavirus says, well, we got to make a target. And as it turns out, everybody comes up with the same target, which is the spike is so important, both in terms of its characteristic and in terms of its important function of getting onto the inside of a cell. Why don't we target the spike? So let's make a vaccine, okay? So the most important thing is that in order to target the spike, you have to be able to figure out how you're going to make the spike. So I'm going to take you back to the origin of this entire pandemic in Wuhan. And on December the 8th is probably the very first case that they can identify. And then you can see cases coming out of the Wuhan marketplace, and they begin to wind up transmitting to other people who are not even in the marketplace, and you hit a pandemic, and finally the pandemic is under control and gradually quiet down. Now, we're not going to relive the epidemic of December and January of 2019. The only reason for showing this slide is because of the fact that 1 month into the epidemic, the CDC in China has figured out what the sequence is. And this is the gentleman who is sitting on that information. He worked day and night, literally, to be able to figure out the gene sequence of the virus. And then he's sitting on something that's a little bit of a dynamite. Because by January the 11th, Dr. Zhang knows that he has to be very careful politically because his colleague, Dr. Li, the whistleblower, has already been censured. So he wasn't quite sure just exactly how to get that information out. Thought about it, thought about it, thought about it. Connected with a colleague of his, a very prominent virologist by the name of Eddie Holmes in Sydney, Australia. And once Eddie Holmes got the information, this is 2020. What do? You tweet it out. So this is the tweet that was heard around the world, being fired out of Sydney, out of virological.org, and they are basically saying, hey, this is the gene sequence. The minute that you have the gene sequence, you can figure out how to basically make it in a test tube. You can then figure out which part of the gene is going to be important. And you can definitely wind up saying, well, this is the region that's making the spike. So let's concentrate on this and make our vaccines out of it. Now, Dr. Zhang was not wrong. He had every reason to be cautious because very shortly after the release of that gene sequence, his lab was shut down, and it was shut down for rectification, whatever that means. Now, everybody then asked me, is Dr. Zhang okay? Meaning, did he disappear? The answer is no, actually. He has continued to be very quietly doing his work and talked about the time that he was looking at the gene and releasing the information. And he understands that it is a critical piece of information that he cannot sit on. The world has to know. So the last interview with him was just a couple of weeks ago, and that was on the occasion when Time magazine decided that he is one of the most important person in 2020. So he's on the Time 100 list. And indeed, there's no question whatsoever that that unique signature of the spike protein is going to wind up making us do things that would allow us to combat this very deadly virus. So it is an RNA virus. Going through the sequence, they can identify the portion of the RNA of the virus that is making the spike. They then can isolate that particular portion and make multiple copies of it. And when we're talking about the Moderna vaccine, the BioNTech Pfizer vaccine, we're talking about messenger RNA vaccine. So the RNA vaccines are definitely important, and there is no question whatsoever that they are targeting the region of the spike protein RNA, and they are making multiple copies of the RNA. They then go on to put it into tiny little nanoparticles of lipid so that they would be able to inject it into the patient and allow it to go to your own cell. And with the lipid liposome, you're able to allow the mRNA to go into the inside of a cell. Once you're on the inside of a cell, we've got multiple of these 3D printers that are going to say, if this is the software telling us what to do, this is what we're going to make. We're going to make the spike protein. So now you are utilizing the human cell, utilizing the message coming from the RNA of the virus to make spikes. So now you make a lot of spikes. And when you wind up with the spikes that's being recognized in the body, the antibodies are going to be formed by the B cells, and the infected or the ones with the spike cells are going to be killed by the killer T cells. And this is going to be an immune response over a brief period of time because the messenger RNA is going to self-destruct, and eventually this entire process is going to stop without a great deal of fanfare or adversity to the host. The entire T and B and all that junk is going to be kicked up. And what is important is that if Rona actually comes in and there is a coronavirus attack on the host, you then kick out the immunistic response and be able to kill the virus with antibodies that's going to prevent the entry coming from the B cells, and with T cells that are going to kill the infected cells. So that's the basic premise of the RNA viruses. Now, as you know, there are multiple other viral agents, and the AstraZeneca virus vaccine is a little bit different. They don't want to use these liposomes to introduce the genetic material. So what they say is, why don't we find a virus that's going to wind up infecting the human cell and put the genetic material into this virus and send the virus in? And the important thing is, let's choose a virus that's not particularly toxic, and let's inactivate it so that it doesn't wind up replicating. And in that setting, we would be able to put the genetic material onto the inside of these viruses, and almost everybody is choosing adenovirus, which is the virus that causes very, very mild cold. But more importantly, they inactivate the virus, and that inactivated virus with the genetic material is going to gain entry onto the human cell. Once they get into the human cell, the genetic material is released. They're going to make the messenger RNA, and they're going to, again, utilize the cell's machinery to make lots and lots and lots of spike protein. So that's the AstraZeneca University of Oxford vaccine. Now, they not only chose an adenovirus, they were concerned about the fact that when you give an adenovirus vector, patient may have been exposed to the common cold before and already have antibody against the adenovirus. That's obviously going to decrease the effectiveness of that particular vaccine. So they decided that the viral vector that they're going to choose is actually a chimpanzee adenovirus. So their vaccine is called CH for chimpanzee, AD for adenovirus, OX for Oxford, 1. So that's the viral agent that they are sending into our body in the clinical trial. Now, not infrequently, people are going to say, if you're interested in the spike, why don't you just make a lot of spike? Well, that was actually one of the first things that I thought about as well. Although we're interested in the spike, why are we doing these DNA, RNA type of process? Why don't we just make the spikes? Well, as it turns out, there are companies that are going to just make the spikes. And you have heard about the top 3 candidates that are coming down the line. In position number 4 might be J&J, or it might be this upstart of a company called Novavax. Novavax says we are going to wind up doing things so that we make the spike protein, because we know the gene sequence. We're going to make the spike protein. Now, how are they going to make the spike protein? Well, they put the spike protein sequence into a virus. And the virus that they put it into is called a bacuvirus. And what that virus is going to do is to penetrate into the inside of a cell. But that's not a human cell. That's a moth cell. So they're going to make the moth makes plenty of these proteins. And all of these proteins can be harvested, and they're going to impregnate the protein onto a nanoparticle, mix it together with some adjuvant, inject it into the patient, and the patient's going to mount lots and lots of antibodies against the nanoprotein with the spike, and they are now in a clinical trial. And the interesting thing is that they have finished the clinical trial in the UK. We haven't seen the data yet. They are starting the US trial at the end of this month. So this is going to be possibly in position number 4 as far as the vaccines are concerned. Now, the thing that is problematic is that I can go on and on and on because there are a gazillion people making it, okay? And this is going to be the magic. The magic is going to be that there are enough of the companies that are going to make it that sooner or later we're going to make enough doses to cover, hopefully, the globe. So the problem is making the vaccine at warp speed. And all of you are now enjoying the fruit of Operation Warp Speed. And when that came out, I said, what is Operation Warp Speed? And they sent me that. And I said something that's not particularly repeatable, because by the time that you wind up with Health and Human Services interacting with the Department of Defense with an org chart that sort of runs every which way, you're going to wind up saying, this is not going to work, okay? But it does. Because ostensibly, what we're talking about is this incredulously gifted person who has made a lot of vaccines before, who wind up overlooking the making of the vaccine. He identifies the company that are most likely to succeed, and he selects them for Operation Warp Speed, and he selected 6 companies. On the other side is the Department of Defense. And at the beginning, I said, oh my God, what's the Department of Defense doing? Well, this particular person is going to be responsible for the logistics of getting the virus from point A to point B. And all of a sudden, I kind of say, wait a second here, the military definitely can get things from point A to point B without messing around, and they don't tolerate a lot of craziness. So that's that entire org chart boiled down to this particular level, because we're trying to create a vaccine in pandemic speed. Normally, a vaccine is going to wind up taking 10 years in production because of the fact that you go through a very methodical way of making sure that you understand what that target is. What are you going to make as a fake Rona? You're going to wind up trying multiple candidates until you find the one that's going to be by far the best. You then are going to wind up doing it in animals to make sure that it is not toxic. You're going to wind up making sure that it is indeed going to do what you think it's supposed to do in the animals. And then you're going to wind up going to the FDA and apply for a license to go into human clinical trial. At that particular time, you're going to be making a small amount of a clinical trial material. And if the phase 1 trial tells you that we now know that it is totally safe in human, and we also know that the proper dose ought to be this, this, or this, then you go into phase 2A to take a look at its efficacy. It's only when you know that it is actually efficacious that you begin to make more of this particular protein so that you would be able to have enough to do the phase 3 study. You make just enough to finish the phase 3 study because of the fact that if the phase 3 study is a bust, then you don't want to be manufacturing at scale. But if it is effective, you're going to then go into applying for the license and making a lot of the protein. This particular process traditionally can take up to 10 years. The fastest that we have ever done it is with the Ebola vaccine, and that took 4.5, almost 5 years. What happened in the process of this particular pandemic is that we don't have 5 years. So we're just going to wind up saying, hey, you do all of the preclinical stuff in the background. Just tell us that it is a reasonable target, and we're going to wind up making clinical material so that you can go into safety and dose selection. You can take a look at the efficacy. And by the way, by the time that you see a little bit of clinical efficacy and you're sure that the target is not going to get you into safety issue, go ahead and go on to large-scale manufacturing. Wait a second here. You mean I'm going to begin to make gazillion amount of a clinical material that hasn't been approved, whose efficacy we're not sure of? Operation Warp Speed says, yes. Why am I doing that? That's a very, very risky proposition. No, it's not. Because we're going to pay you for this. We're going to buy something that you haven't even invented. We're going to buy millions and gazillion doses of vaccine you haven't made. So it is at no risk to you. The risk is on Operation Warp Speed. Whoa! You're going to buy something that I haven't even made? Oh my God! So this is what facilitated the thing to allow us to make a vaccine in 11 months. So phase 1, phase 2, lots and lots of papers on each and every one of these particular processes. Every day there's yet another vaccine whose clinical efficacy and phase 1, phase 2 data are coming out. Suffice it to say, the bulk of it just basically say that this is a very easy target. The spike protein is something that is highly efficacious target. It is safe. When we wind up doing these in volunteers, it appears to have very robust production of neutralizing antibody, and we are activating the T cell, so we know that we can create a situation where there is a memory bank, and we are hopeful that when they get infected, the entire machinery is going to come out and combat it. Not going to talk about phase 1 and phase 2 because the only thing that we're interested in is, does it work? Okay? So the large-scale efficacy and safety trial. I'm going to slow down because of the fact that everything that we're going to do is predicated on understanding just exactly what the efficacy is and what the safety profile is. So first to the block is BioNTech with Pfizer. BioNTech is a German biotech company that has been working with messenger RNA for a long time. So Pfizer has worked with BioNTech before and obviously has the capability of making a gazillion amount of whatever vaccine you're going to be able to make and be able to distribute it. So we picked December the 9th to have this particular lecture because on December the 8th, we all get to see what the data BioNTech and Pfizer submitted to the FDA. And what we know is that they have enrolled 44,000 patients. Half of them received placebo, the other half the vaccine. It's a 2-dose regimen separated 21 days apart. Now, what are they looking for? Well, they're definitely looking for side effects, looking for safety, looking for all sorts of parameters. But the most important thing is that nobody knows who is getting the vaccine and who is getting the placebo. So they just sit back there, and out of the 44,000 patients, they patiently wait and wait and wait for infection to occur. Now, they don't know whether the people who are infected are going to turn out to be vaccinated or placebo. But they have to have enough infections so that they can see what the effect of the vaccine is. And what the FDA very clearly said is that, yeah, Pfizer, you guys had one of these interim look at 32 patients. Don't bother, because whatever the data came out with 32 patients is not going to get you approval. It may get you interested in how you're going to wind up designing things, but we've got one shot at this. You just go, roll with the dice. So finally, we got more than 150 instances of infection. So let's break them down and see what happened. Well, first of all, out of the 44,000, there are every parameter under the sun that they're going to be looking at. Male versus female, the sex of a patient at the time of vaccination, stratified to the various groups, the ethnicity of the patient, whether they are American Indian, African American, Asian, or Native Hawaiian. They just have all sorts of process that reflects roughly what the composition of the population in the U.S. is. So I look at that and say, pretty heroic, and obviously a lot of foresight in making sure that that happens. So out of the 181 infection, 172 was in the placebo group, and only 9 were in the vaccine group. So that would mean that you successfully wind up protecting the vaccine population with an efficacy of 94.8%. That is astounding. And nobody died. But equally importantly, there are 10 people out of the 181 that wound up with very severe disease, enough for them to be hospitalized. And out of the 10 with severe disease, 9 of them were in the placebo group and 1 in the vaccine group. So again, a reminder that it is a 2-shot deal separated 21 days apart. And let's take a look at what happens when you inject the first dose. Now, you understand that there's going to be a group of patients that got placebo. So they're the ones that are going to wind up cumulatively continue to get infected. And the question is, after the first dose, what happens to infection? And this is pretty dramatic. So if you take a look at the placebo group, they got nothing. So with every passing day, there's going to be somebody else that's going to be infected, and they keep accumulating, and they are basically going up in a straight line. The vaccine group, you almost can't see it. At the beginning, within the first 7 days, there's no protection. They're parallel and identical with this line. But starting at around the 10th day, it is beginning to level out. And 21 day is when they get the second shot, and you can see that the likelihood of you getting infected after the second shot is pretty small. And that's how you come up to the fact that beyond 7 days after the second shot, you are protected to a 94.8% efficacy. So let's summarize. It is effective for all ages tested. It is effective for all ethnicity tested. It is effective for people with associated comorbidity, diabetes, hypertension, hyperlipidemia. They are beginning to see an effect 7 to 10 days after the first shot. But after the second shot, it is very clear that this is a very protective vaccine. Now, more important than whether or not it's effective, the fact that if you get sick, you wind up with very mild disease is of paramount importance. Because I would say that I don't mind having a mild disease. I just don't want to be sick. And this vaccine seemed to be able to, 1, decrease the likelihood that I'm going to get infected, and 2, God forbid if I should get infected, it's going to be a milder disease. So they applied for the emergency use authorization November the 20th, 2020. And I chose this particular timeline because of the fact that in order for it to be reviewed by the Scientific Advisory Board, they have to release the information yesterday, Tuesday, because the Scientific Advisory Board meets on Thursday, tomorrow. Now, I can pretty much tell you that there's a large amount of information. It's not just efficacy. It's not just the distribution. It is the manufacturing up to quality? Did they abide by each and every one of these 6 million rules that we have in making things? So a lot of things are going to enter into what the FDA is going to be looking at. And it is not a minor chore because of the fact that when asked, why can't you speed it up? Steve Hahn says, well, when I get the data, which is going to be 2 days before December the 10th, I'm going to have 150 people working around the clock, nonstop, to process the information. And if we try to just hurry the information around, then we're not going to be doing the vaccine justice. Because as all of you know, there's always going to be some problem as far as concerns over the vaccine is concerned. So what would I think is going to happen? It's going to be approved on Friday. And what do I think is going to happen? The military is going to be airlifting this to all 50 states. How do they decide how much to ship? Whatever this shipment is, they're going to divide it according to the density of the populace of a state. Now, one of the things that's going to be awkward is that this is going to have to be stored at minus 92 to minus 94 degrees, which means that everything is going to be on dry ice. And it's going to be difficult for a physician's office to be handling this particular process because you are going to be running around looking for dry ice. So there's no question whatsoever that I am hoping that by next week, the hospitals will be getting it and the long-term care facilities will be getting it and the vaccination will go underway. Moderna. Moderna wound up with their information coming out. We have not seen the final package, but we know what the preliminary information says. 30,000, again, 1-to-1, placebo versus vaccine, and they wound up with 196 infection endpoint. And out of that, 185 were in the placebo group, and 11 was in the vaccine group, again, giving us almost an identical efficacy of 94%. Now, out of the 196 infection, 30 of them were sick. All of them. All of them. All of them were in the placebo group. There was one death, and it was in the placebo group. You look at that and say, whoa, wait a second here. There is hope. So they applied for the emergency use authorization November the 30th. The next time that the board is going to meet is December the 17th. And I think that knowing what we know about the preliminary data, we would expect that on the 18th it's going to be approved. And again, on a Saturday, we're going to wind up with shipping of all sorts of vaccines all over the country according to the pre-plan of the density of the populace. So they're very quick to point out, you don't have to store my vaccine at minus 94 degrees. You can just put it in the freezer or put it in the fridge. And even if it is in the fridge, it's good for 30 days. Clearly, a lot more user-friendly to use. AstraZeneca. Well, AstraZeneca was in the lead for the longest period of time and all of a sudden wind up falling off of the lead. And they have enrolled to date a lot of patients, but they released the preliminary data on 11,336 of them. And the publication came out today. And they divided their results according to how the vaccine was given. And what they saw was that in one group of 2741 patients, they wound up giving a half dose of the vaccine first, and then a month later or longer, they wound up giving the second dose. And then the second group wound up getting full dose, separated 1 month apart. And the Monday press release was, hey, we got 90% too. And people look at that data and say, which group? Well, in the low dose, standard dose group. Why do you all of a sudden have a low dose, standard dose? Well, they were all in the UK. They were in that first wave of patient that came about, and it's normal volunteer between ages of 18 to 55. And they got half dose because we screwed up. What do you mean you screwed up? Well, the people who were counting the virus mixed it up, and they only gave half the dose of the chimpanzee virus. So it wasn't something that you planned. Nope. It was something that just happened. Yep. Okay, so what happened to the rest of the group? Well, in the full dose, the efficacy is 62%. So when you combine the two groups, it's 70%. Now, remember, when we started this game, we said anything that is 50% efficacy we'll take, okay? It's only when we wind up with people saying, I got 94.8, I got 94.5, and this kind of a thing, that all of a sudden, 62% look pretty awkward. And everybody is saying, wait a second here, you can't just combine the two, okay? So if you are sure that this is legit, then you need to do a protocol that's half dose, standard dose, and plan it that way. So why is it so messy? Well, this publication came out this afternoon, and we understand why. They're running trials all over Kingdom Come, in Brazil, in South Africa, and UK. The US data is not in there. And they are still ongoing, so this is an interim look. And there is no question whatsoever that the slightly different study design make it kind of messy as well. And more importantly, they changed the protocol when they saw that people only got half the dose. They were still allowed to go on with the trial. And more importantly, the placebo group is a funny placebo. They didn't get placebo. Most of them actually got meningococcal vaccine. So the low dose group are all in the UK, all young. And because of the fact that they figured out they screwed up, the second dose is given much later than the designed 28 days. Now, it appears to be really, really real, but we don't know why. So at this particular time, I think that we're sitting on pretty messy results. And they're also the one that keep running into roadblocks with short-term safety data. There was one case of multiple sclerosis described very early on. They decided that it's not related to the vaccine. And then there was a case of transverse myelitis in England that definitely slowed things down. And in the US, they didn't get permission to proceed for 5 weeks, which automatically screws up the study because you're supposed to have dosing 28 days apart. And there was one death in Brazil, which became a political issue. And there's no question whatsoever that we wound up having to hold a trial there. So it is kind of rough. So at the present time, we have this particular phase 3 data. They understand that publication by press release actually came back and hounded them because of the fact that the scientific world was very, very unforgiving with the way that they tried to portray and put their best foot forward with data that was never intended to be a part of the protocol, with people that are quite young, all below the age of 55, with the second dose given at varying times long after the 28 days. And they say, wait, if you think that that is real, do it all over again. So AstraZeneca is going to be slowed down. Okay, so at the present time, I covered 3 of the top tier. Number 4 is either going to be J&J or this tiny little engine that could, the Novavax. So, yeah, we understand that you threw gazillion amount of resources into making it fast. But did you take shortcuts? Is it safe? So let's take a look. This is awkward because of the fact that we are definitely sitting on the largest clinical trial on Earth ever conducted on vaccines. So far, we do not see a lot of brouhaha, but you have to understand that to say that this is going to be safe is going to be a very significant statement that you cannot make, because these are novel vaccines. None have been approved, with the exception of one viral vector vaccine against Ebola. So we're not going to wind up knowing what the outcome is going to be. So I asked a whole bunch of people who's very, very smart and say, you know what? What does it take for you guys to feel comfortable? And they say at least 3 million people for 5 years. And I said, no can do. We don't have 5 years, okay? So we're going to wind up with billions of people getting vaccinated, and we're going to be learning on the fly. And there are no question whatsoever that people are going to begin to raise eyebrow when something who just came out 4 hours ago is it's going to be on the front page tonight and tomorrow. Meaning that we very seldom think about allergic reaction to vaccines. And in the studies to date, it is accounting for 0.6% of mild allergic reaction. But even the placebo group seems to have 0.5%. But what is problematic is that this afternoon, this report came. 2 people who are healthcare workers, both with history of severe allergy, both carry EpiPen. We don't know what they're allergic to, but when they were given the vaccine, within a very short period of time, developed what they call anaphylactoid reaction. Both were treated very promptly. Both are doing fine. Now, what is the U.S. experience? The U.S. basically said, in all of the trial, we have very specifically excluded patients with a history of severe allergy. So there's no question whatsoever that when you wind up saying anaphylaxis, you're going to wind up saying, wait a second here, that's going to be a big roadblock. Well, I think that it's going to be a roadblock. I think we're going to have to understand exactly what happened. I think that Britain has already declared that they're just going to wind up saying, if you have severe allergy and if you carry EpiPen, you are not to receive this vaccine until we understand what's going on. So I am hoping that the Scientific Review Board is going to view it as such as well, and basically wind up saying the same thing, but would not hold up its approval. So we don't understand what these allergic reaction is all about. Now, we do know that when you get the injection, there's going to be local reaction to it. There's going to be pain and swelling and redness. A lot of the patients are going to wind up with fever, malaise, feeling blah, but that's going to be gone for 24, 48 hours. The second shot seems to generate a little bit more of the immunological response. So in Britain and also towards the later part of the U.S. trial, it is generally recommended that why don't you start Tylenol after the shot and continue it for 24, 48 hours. The problem is going to be the long-term theoretical concern. We don't know what it's going to be. We know that there are unforeseen circumstances with other vaccines, such as Guillain-Barré syndrome. Molecular mimicry means that the vaccine looks somewhat like certain tissue, and then you're going to wind up attacking your own tissue. And the tissue that you're most concerned about is going to be the spinal cord and the brain. So these are very rare complications, but they are of theoretical concern. So how long does the immunity last? Well, we know that with natural infection, we're beginning to see that 6 months out, there is still antibody level that's measurable, and there is still T-cell activity. And in the clinical trials, we can see that with the vaccination, neutralizing antibody goes up and stays up. This is at the 3-month point, and it appears to be staying up beyond that. Now, the dotted line is a single dose. If you only give a single dose of a vaccine, you would say pretty good, but unfortunately it begins to fall, which is why a lot of these trials are now asking for a second booster shot. So how long are you going to be protected for if you are vaccinated and have antibodies? We don't know. But I think that it's going to be greater than 6 months, and I think that the T-cell response is going to be greater than 6 months as well. So can I get infected if I got a vaccine? The answer is sure. Because even with 95% efficacy, 5% of the people who got the vaccine got infected. Now, more important than that is that they are only looking for people who have symptoms and count it as an infection. And you know that this virus is sneaky, and a lot of them may be infected but are asymptomatic. Do we know? We do, actually, because in the AstraZeneca paper that came out this afternoon, I was interested to find that there was a tiny subgroup of patients in the UK that wound up doing home nasal swab and sending it in for PCR assay on a weekly basis. So they don't have infection, but what is interesting is that a small group of those particular patients turned PCR positive. So there is no question whatsoever that you can get infected. The infection appears to be mild. Nobody got very critically ill, and to date, of the data that I have seen, none of the vaccinated people died of COVID. So, now, let's think about it. One of the questions that I want to address is going to be, if I get the vaccine, can I take off my mask? Well, it depends upon whether or not you're still infective. Meaning that if you wind up with symptomatic or asymptomatic infection, are you going to pass that virus on? No clear answer, but I think so. And I'm allowed to think whatever I want. Now, why do I think so? Because whenever I'm in doubt, I go back to situations where we have control, and the control is in animal studies. The animal studies are all done on this particular breed of macaque monkeys, and they are running out of macaque monkeys because of all of the preclinical work that's being done. But in essence, in an animal study, what you're going to wind up doing is to vaccinate half of the monkeys and leave the other half with a placebo. And all of them are given high doses of coronavirus. They don't wind up giving it in the ear. They actually put a tube into the trachea and shoot the virus in. So it's a high dose of virus. What is interesting is that the vaccinated animals appears to be protected and they don't develop pneumonia, whereas the control animals develop pneumonia. The good news is that macaque monkeys tend to be pretty tough and they don't die from this pneumonia. They just get very sick from it. So what is going to be important is that while they are looking at the control animals, virus is everywhere. They're clearly in the upper airway, in the lung. They're going to transmit the disease. In the vaccinated animal, virus wasn't found in the lung, but it depends upon which vaccine you got. It depends upon how high the dose was. The AstraZeneca vaccine did not eliminate the virus from the upper airway. So I do believe that the thing that's going to happen is, one, if you have a vaccine, there is still a chance that you're going to get infected. If you get infected, I think you can pass it on. And therefore, your question about whether or not you can take the mask off has to be considered in that light. So, what's going to happen now? What's going to happen is obviously 6.4 million doses are going to be shipped across the U.S. And there's no question whatsoever that in December and January, they're going to be going to the healthcare workers and the long-term care facilities resident. Healthcare workers need a break. There's no question whatsoever that a lot of them barely drudge through the first wave. And with the current surge, where the entire country is red to purple, there's no question whatsoever that people are at the breaking point, and it would be important at least to protect them so that they won't get demoralized. Long-term care, 6% of the population, 37% of the deaths. And we see all too often these particular scenes where they're totally isolated and their weekends is going to be waving to their families. So I don't think that there's any question whatsoever that the initial allocations are going to be going to these two groups. Next is going to be highly debatable. It depends upon whether you want to save life or whether you want to save the economy. If you want to save life, definitely the elderly and the medically compromised. If you want to keep the economy going, keep the people who are responsible for making the economy go protected. Not going to get into that because from day one, I have never gotten into the political aspect of this particular process. My job is to give you the science. You draw your own conclusion. The hope is that 100 million doses are going to be 100 million people, which is 200 million doses, are going to be out there by February. And from May on, I would think that anybody who wants the vaccine can get the vaccine. For the foreseeable future, we're going to wind up having this fear of missing out, making the vaccine one of the most hotly sought after commodity. And anybody who knows anybody is going to try and see how they can wind up being in the front of the queue. So, what happens if you don't get the vaccine? Well, you just continue doing what you've been doing for the last 11 months until the cavalry arrives, or until such time when enough of the population is inoculated that the virus is not going to spread rampantly. Now, the problem with not getting infected is obviously, not getting the vaccine is going to be kind of tricky, because the people who wind up getting infected is going to infect you. The people who are infected but are asymptomatic is going to infect you. The people who got infected but not yet producing symptoms are going to infect you. That's bad enough. But even vaccinated patients may be transmitting the disease, okay? So you are just basically sitting there getting fired upon on all fronts. The benefit is you don't have to have any of the ambiguity about the short-term or the long-term side effect of this particular vaccine. What if I am lucky enough to get vaccinated? This is hard. You continue on social distancing. You continue on masks. You continue on hand hygiene, because the last thing that you want is to rub it in, okay? You may be protected, you may not. But if you get infected, you're still going to be passing it on. So there is an innate responsibility for you to try and look out for everybody around you. So you still can get infected, but 95% efficacy, I'll take that. If I get infected, it's going to be mild. Good. But I won't die. I won't go to the hospital. But you do have to understand that we don't understand the long-term ramifications of these novel vaccines. So you are taking a chance. I think most of the people in the science are going to wind up taking it because of the fact that they've looked at all of the ramifications and understand that the long-term problem is theoretical problem. And if you calculate out the statistics of if I am 78 and I have this, and this, what is the likelihood that I'm going to do well if I get infected? Then it becomes a very, very easy choice. So I think that these are all of the things that are going to happen. So let me take a few minutes to basically answer some of the questions that have been posed. So the first one is very cute. Can I hug grandma after I get the vaccine? Well, first of all, not until 7 to 10 days after the second vaccine is given, but actually you cannot hug grandma because grandma needs the vaccine before grandma can see you. Now, can I go to Europe after the vaccine? Well, again, wait for about a week until after the second dose. That way you will be sitting on the 94.8% efficacy. You still need to use social distancing. And people say, so when is that going to end? And I say July the 8th. Because right from day one, when people ask me, when is this going to end? I said July the 8th. I never told them what year. So I'm going to say July the 8th again. But most importantly, Europe may not want us. I mean, we have definitely not been model citizen when it comes to the way that this pandemic has basically totally run us over like a train. School. Now, this is going to be a problem because children are not going to be vaccinated anytime soon. At the present time, all of the data is for 16 and up, and we're beginning to take a look at age 12 and up. But the thing that's going to be important is that if the adults and the teachers are vaccinated, I think that it is going to be quite safe for the school to open up. But that's also predicated on having the ability to test, and test. Will the economy open with the vaccine? I think in stages. I think that it's going to be gradual. I think that social distancing is going to continue until July the 8th. So can I go to a Red Sox game? Spring training, probably not worth the trouble. Opening day, quarter attendance, social distancing, and mass. World Series, 75% attendance, should still wear a mask, but you can take it off to boo. So, is this virus going to be smart enough to mutate and make all of these vaccines that are keying in on the spike protein irrelevant? The answer is that there are genetic drift almost every day, but so far, none has significantly affected the spike protein in the critical binding area. And all of the vaccines that are made so far is going to wind up being quite effective. Now, obviously, we don't know what the future is going to wind up bringing. But what I'm going to try to say after going through all of this is that there is hope. But it's not just a jab in the arm. Hope is going to take all of us trying to help all of us. But I do believe that there is enough intellect and science behind this particular Project Rona that we're going to be able to win the war.